Hi guys, welcome back to my YouTube channel, and today I'm up with the next question of top 150 interview questions of Lead Code. So let's get started with the today's question. Today's question is to group anagrams. We are given an array of strings. We have to group all the anagrams together, and you can return the answer in any of the order that we have. So we are given an input string eat, oggy, coggy, and I have the expected output is I've collaborated all the anagrams together in one of the strings. So let's get started with the discussion of the same. I think the most intuitive solution to this problem lies in the fact that we will store all the grouped anagrams, uh, like what we can say in some map, in a map of string with a vector of strings, with an array of strings being stored, in which I will in which the key would be the sorted sorted order of that sorted order of that string on which we are working, and in that vector we are storing all the anagrams of that string. So this is one of the expected solution that I can think of while after just reading this question. So the time complexity involved in this solution is so before just discussing the same, let me just make one of the example for it. Suppose I have eat, so it could be AET, and the corresponding example vector for this would be eat and 8. Okay, and this would be my vector that I'll be storing. And for Augie it would be GGOY, and the corresponding vector that I would be having is Augie and Augie. That's what the that's what it will look like. So the time complexity of this solution would be, first of all, n log n, because we are sorting each and every string, and this would be n times because we have n strings in our strs vector. So it would be O of n square log n. So it's a very big time complexity for this solution. And the space complexity would be big O of n, because we are actually storing all the key value pairs. That's why. So what we can do in this case is we can actually cut the time complexity to we can actually reduce this factor of n log n to n, right? We can actually cut off this log n factor. How? What would be the case for it? So the case for it would be, like I have also discussed this concept in my previous video as well, that what we can do is we can store all these all this sorting in some count vector v. Like what we can do is, rather than sorting this string using the using the standard sort function, what we can do is we can use the technique of counting sort for sorting this string, and we can store that vector of int. Like rather than creating this map, we can create a vector of integer map which will actually hold the count of that the counting sort vector, right? And a vector of string which will actually hold all the values of these anagrams, which will hold all the anagrams in this case. So that's what we can do. Why I'm using this vector of string rather than a string? Because in the counting sort, what I'm trying to actually figure out is, I'm trying to figure out the frequency of each and every character that exists in this string. So suppose I have eat, so what is the frequency of e? It's 1, a is 1, t is 1, right? So storing all these in a vector of size 26 is much easier than implementing a sorting algorithm, implementing the usual sort function. So that's why I have taken up this approach. So in this case, the time complexity still remains n into n, because which is near to O of n square, but this log n factor gets reduced drastically, right? We have actually eliminated this log n factor, and the space complexity still remains O of n because we are storing these results in some another memory, which is a map. So jumping to this, jumping to the code of the problem. So let's discuss the same, right? So what I'm doing is I'm making a count sort vector for each and every string that I'm encountering, pushing these strings in my map, making a key value pair, and then I'm finally inserting all my answers in the answer vector. That's what we are actually doing in this case. And I have also implemented that n square log n solution as well, but I have commented it out for the time being because this solution seems to be the best solution at this point of time. So let's run the code for the same. So the code works fine. Let's submit the code. It works well, although it's a bit slower solution, but not a big deal. But because we have to actually sort all the elements one by one at each and every iteration, so rather than using the n log n function, we have actually used the n O of n function. And one more reason to use that O of n function is that we only have lowercase English letters, so that's why we can implement that solution very easily. So I hope guys you have understood the question. If you have understood, please do hit the like and subscribe button of the channel. Subscribe if you are new, like if you regularly watch my videos, and please do share the video with your friends and also the peers as well if you are working. It gives me a motivation to make more such videos with more enthusiasm. So thank you guys and keep watching my channel.